In this episode, I speak with Kengo Takahashi, a Japanese neuroscientist working on the topic of consciousness. Please enjoy.
This project, in a more bigger picture, it's supported by Templeton Foundation in the US, and there are, like, let's say 20 different theories of consciousness. Of course, you cannot measure all of them, right? Even when you say consciousness, people define consciousness in a different way. So there are some parts of consciousness. So there's something called phenomenal consciousness and access consciousness, and some theories of consciousness are very similar to each other, but some theories of consciousness is completely something different. So you cannot compare something completely different, like between two different things. Even on biologically really test differences of different claims of consciousness, you cannot compare something so far away. So within this project we have four different projects comparing different theories of consciousness, and I was one of the projects comparing one of the theories called IIT, Integrated Information Theory, and Neurorepresentationalism, and active inference.
Okay.
So IIT is Integrated Information Theory is the most well-known theory of the consciousness, literally. By Professor Junior Tononi, and another one, active inference, is from Professor Carl Friston, and his theory is active inference, and the neurorepresentationalism is coming from Cyril, which is my boss, and so all of those three theories claim something similar, but there's some kind of fundamental differences in more biological level, and we are really biologically trying to test if so those biological differences across three different theories are try to at least deny some of the test those differences, so that one of the theories could be more preferable than the others. But to find out what the consciousness is, I don't think you can even figure out next 50 years, 100 years. I mean, this is I don't know how much you're familiar with theories of consciousness.
No.
But this is a very difficult subject. The reason is because traditional science, right? Whatever we do, science like fMRI, cognitive neuroscience, even can be physics. Everything's basically based on observation, right?
Yeah.
And you observe and you calculate. You observe and then calculate and then test. But so even Einstein's this theory is still basically based on observation. I mean, it's driven from observation. But consciousness is something you experience. It's subjective feeling, right? So that you don't have a parameter to observe. Parameter of observers, like, let's say if you feel happy, right, or if you feel sad, can you measure your sadness or can you measure your happiness? Maybe you can broadly tell, like, oh, you're smiling, you maybe look happy, whatever, but there's no measurement, right? You only feel it, that's it. And subjective experience is also the same. Like, I know that I'm conscious because I'm experiencing the world. I'm perceiving the world, right? So that I know that I'm conscious. But I cannot tell if you are conscious or not. But that's purely by observing you. I can assume that you're conscious, but you only know yourself that you're conscious. And this comes to different animals too, right? Like if you have a dog, let's say if you observe the dog, like I had a dog, and he was very happy to see me.
Yeah.
But if he sees you, he'll be angry. So he's clearly, recognizing, the differences between me and you, right?
Yeah.
So you can kind of estimate that the dog is probably conscious too. mice, rats, other animals, at least mammals, they're the same. Same as like, behavior terms, yeah. You could say something the same. But if I tell you that if I tell you that the plants are conscious, you may think I'm crazy or something, right? Probably at one point. But what's the difference between plants and animals? They're also living things, right?
Yeah.
They're not dead.
Yeah.
And so now let's imagine like if mice and rats, whatever animals have consciousness, but what about worms or ants or some whatever living things?
Fungus.
Yeah, fungus. They may also have their own form of consciousness, which it's different from what we imagine, right? Of course, but there is no particular definition of consciousness. I mean, we could also broadly define it, but there's no concrete definition of it. And these people have been, I think that's something called the problem of consciousness. People have been discussing this, like there's no way to test for example.
Yeah.
So that's why that's not something you can figure out next 50 years or 100 years, unless there's something new comes out completely. And yeah, so and particularly nowadays, this is a really hot topic now, actually, because of the AI, development of the AI.
Right.
And many scientists even claim that AIs are conscious. Let's say, but then imagine like if you create a robot, right, who does with the AI and do all the things, and you ask AI, for example, you have a robot, right? You ask AI, "Hey, are you conscious?" And then he could say yes, right? Of course, and he can make any reasonable explanation why he's conscious. But then let's say, this AI computer is or robot is, you don't want to use it anymore, so you want to break it, turn off. And then AI will tell you, "Hey, don't kill me. I feel sad," or whatever, right?
Yeah, yeah.
And that comes to also comes to another ethical and discussion, right? That like you are killing robots, but to me it's a bit stupid. Not as stupid as of course, if TV does not working, people throw away the TV. But how do you know TV is conscious or not, right? So of course, in neuroscience, people, at least scientists are discussing more conscious, some theories of consciousness, and they're discussing that to form the consciousness, you need more complicated system. Yeah. Which that's what IIT explains. But yeah, so at one point it comes to this kind of discussion as well. So it's a hot topic in terms of development of AI, I would say, but also very important for human medicine related stuff as well. Like if you are ALS patients, right? It is ALS, like Stephen Hawking, whose body doesn't move, and at the end of ALS, okay, so your muscles start degrading, right? You cannot move your hands, all the muscles. At the end, they communicate through only eye movements, right? But they're still communicating, like Stephen Hawking. So although communication is slow, clearly they're communicating using eye movements by following the letters, right? But what if their eye movement stops? Are they conscious or not? They're probably conscious, right? Eye movement stop doesn't mean that they will die, clearly, right? So then imagine like they understand, because you talk to them, right? They understand what you're talking about. Imagine like if your body doesn't move at all, you understand everything basically. And then like maybe in the future you have a daughter, right? For instance, like your daughter is my mom is already dead, but you understand, because you're conscious, right? But there's no way to tell if this person is really conscious or not, right? So that also provides at least an essential aspect of the research why this kind of research needs to be done. Okay. Yeah.
So you said that there are hard questions that cannot be solved. Problem. What is consciousness? That kind of questions. But you're doing science here. Like you are testing something based on your measurement with mouse. So what is the particular thing that you are trying to solve?
So what we are trying to do is, so whatever I do here will not, of course, solve the hard problem of consciousness. But what I'm doing here is more specifically about visual perception. Yeah. So consciousness can, of course, switch. Like for instance, right? If you, at one, how do you say, like, like everything you perceive, through visual system. That's what I'm looking at, and based on my experiments, of course, it can lead to eliminating some theories of consciousness. But because this project was funded to contribute to the aspects of consciousness, to understand more what the consciousness is. The project is about consciousness. But when I explain to my lab members or someone who knows my experiment, someone who is doing neuroscience, right, I tell them it's not really a consciousness experiments, but it's more about visual perception. Okay. So in the visual cortex, some neurons, they of course respond to some specific stimuli, right? Like let's say if you see, I don't know, book. Like if you go to theater, right? There's actually theater in Stuttgart, which has the biggest screen in the world. Oh. And I've been there actually. And imagine if you go to big screen theater, right? And then before the movie starts, everything becomes dark. And then suddenly some face of, I don't know, scientist Einstein, whoever, what comes out, you perceive it, right? When you perceive it, your brain in the visual cortex, because you're looking through the eyes, right? Yeah. Your visual cortex becomes active, right? But not all of your brain becomes active, of course, right? As you know. So even within the visual cortex, so of course, like for instance, right? If you see picture of Einstein in a movie theater, probably your auditory cortex doesn't get activated unless there's a sound, right? Of course, if it's completely silent, and so your visual system becomes active, right? That's basically retinal topic mapping, right? When you do fMRI with a retinal topic mapping, and even when you look at the retinal topic mapping, not all the visual cortex becomes active. Of course, some portion of neurons in the visual cortex becomes active. Yeah, that's the retinal topic mapping, right? Basically, and so different theories of consciousness claim the role of those active and inactive neurons differently. They interpret something different. So, like, some people claim that. Let me explain something else. Actually, for instance, one of the two main different theories of consciousness. One is IIT, which I'm testing. Another one is global space theory. Anyway, like there's two big theories of consciousness. Yeah. One of them claim that consciousness arises from the posterior part of the brain, like somewhere close, more parietal cortex and visual cortex. The other said more frontal cortex. They claim that frontal part of the brain is important for areas of consciousness, but some theories say in the posterior part. So people claim different location of origin of consciousness. Okay. I mean, there's no one particular place it arises consciousness because it's about networks often the time. So it's about network, but different origins, different roles. Okay. And in my topic specific, it's more about visual system. Even in visual system, it's not like one particular part of neurons contributing consciousness, but different. For example, Carl Friston, this active inference and IIT by Juliet Tononi, they also claim different neurons contribute differently. So that there are some fundamental differences in terms of more like neurobiological level. So I'm looking at in a more visual system how different type of neurons will really contribute to consciousness. Yeah. I'm not sure if it's understandable.
Yeah, it is. So like, when you interpret your data, what you're looking into is whether neuron or neuronal network A is activated prior to neuronal network B. Is it like temporal thing, or is it more on and off binary kind of thing?
It's more on and off binary things. Okay. So because there are many different kinds of neurons, right? Yeah. And some specific parts of the neurons are really contributing to consciousness. I mean, switch off visual perception or not. So it's not really contributing to consciousness, actually. If it's really contributing to visual perception or not. And by revealing this, it can lead to different theories of consciousness, more or less like that.
Okay.
So if I go to, for example, I don't know, neuroscience conference, when I talk to other neuroscientists, I don't really say that, I'm doing consciousness research, but it's more about really research of visual perception.
Okay.
Like that, yeah.
And then the method you're using is with wild type, or is it like you make lesion in one group and compare with control?
So it is a transgenic animals. So in terms of wild type or knockout, it's wild type in that sense.
Yeah.
So it's very healthy animal.
Okay.
There's no lesion or anything. But we do optogenetic manipulation. So they are very healthy, normal type of animals, mice, and by artificially activating or inactivating some neurons using optogenetics, then in terms of like temporary, we make them activate, inactivate some parts of neurons. Okay. So no longitudinal deficiency of particular neurons like that.
Okay.
Yeah.
Nice.
So only during the experiments, when animal is doing the task, we inactivate some or activate, inactivate some portion of neurons which I'm studying particularly. Okay.
I was Googling about consciousness research, and I saw a news about IIT theory being attacked by so there were like hundreds of scientists signing, but I didn't read through. Do you?
So that was the first part of this bigger picture of the project.
Oh, wow.
So this is something called experiments from Cogitate, which is so like I said, as I said in the beginning, I said that there are 3 or 4 different big projects comparing different theories of consciousness, and not the one I'm comparing, but in this project they were comparing this integrated information theory, IIT, and then global space theory, global space network. I forgot the name. So they were comparing this, and this project this project started way before my project started. So this is independent project, but under the same budget, the same bigger framework, I would say. So this is also by the Templeton organization. Okay. And I think they started in 2018, 19, something like that. I don't remember. But so then I think first update, I don't think they have concluded this study yet, but they were comparing 2 big, most famous theory of consciousness, right? I mean, they were maybe comparing 3 or something like that, but at least 2 most famous theories. And so when they perform this experiment, so including my experiment, this is all very well discussed in advance. So before we even start experiments, they do plan all the conditions of experiments, and all the theories they have to agree that they will test this, and then of course, if experiments goes well, one of the theories will be not removed but degraded, like looked down, right? Basically, so that but that's science, whatever the output comes, that's it. So they did first part of the experiments, and so experiments didn't really favor to one of them. Actually, it was kind of intermixture of the results was kind of intermixture of supporting both IIT and the global network theories. Okay. But the theories was a bit more favorable to IIT actually, if I remember correct. And then why I don't know, it went to that direction because IIT is something. IIT was, I think, that's the one of the very few theories, or can be only one, which try to explain consciousness just purely by mathematics and calculations. So there are a lot of mathematics involved, and to prove this, you need a huge computational work, which is, I don't even know if it's actually possible to prove it, so because it's really difficult to experimentally test IIT, I think some scientists took it that this is a pseudoscience.
Okay.
Because it's there. It's not only because of the difficulty. It's true that there are some. IIT is not the perfect form of theory because there are a lot of what's called this, not mistakes. How do you call it? Something.
Assumptions. Assumptions.
Assumptions or the non-favorable results.
Okay.
Because when you form the theories, right, you test multiple different things, and of course some of the results will not really favor IIT. There are a lot of criticism about IIT too. Of course, that's no doubt. Many people criticizing it, but I mean just theory, right? So of course one theory is not going to predict everything 100% perfect. Of course, some of them might be true, some of them might be might be not. And then I think quite a lot of researchers took it as pseudoscience because it was not maybe because of a lot of criticism. Criticism was like no failure was good. The points that not so clear.
Okay, so it was a reaction to this result from.
I think exactly.
And these people who signed were not involved in this project?
Not my project, for sure. In my project, none of them is involved.
Okay.
But it's I'm sure some of them are involved in one of these big framework of the project.
Okay.
That's for sure. Because I saw some names which is part of this Templeton project, but also part of this. The paper that came out.
Wow.
Yeah, not within my framework. Yeah. That because that was included really famous scientists working on consciousness research. But yeah, I think that was too much. I think
too much, too harsh.
Too harsh. I think so. I mean, IIT is not like complete bullshit, right? It's of course it's hard to prove it, but hard to prove doesn't mean that it doesn't exist or like pseudoscience. It's not like random things. Like pseudoscience sounds a bit different to me.
What part of IIT is convincing to you?
Because I don't even fully understand IIT at all. Like IIT, if you study IIT for 6 months, I don't think you can even understand. To be honest.
So it's some part. It's heavily mathematics and no, not so much biology.
There is biology, like of course. For example, like how consciousness arises in the brain. No, it doesn't have to be brain. Like, so IIT claims. I think if I remember correctly, I might be wrong. Okay, I might be wrong, but if I remember correct, IIT can, based on IIT, consciousness doesn't have to arise in the brain. It can be in machine or whatever complex system.
Okay.
So you need to have a complex system. That's for sure, but not necessarily that consciousness exists only in animal brain. So any complex system. So that's also one thing that people have, I think, we are criticizing. I think, but yeah, either way. So in terms of the brain, IIT claims that because IIT's claim is that mostly consciousness will be arise from posterior part of the brain, which is called hot posterior zone, something like this.
Yeah.
But it has to have certain criteria to arise a consciousness. For instance, like they have to have a kind of like a grid-like structure. So some organization of anatomical organization or neural organization is important to arise. So they has to have certain structure, and it's always about cause and effect, at least in the visual system, this retinotopic organization is something complicated enough to arise a consciousness. That's what I'm working on. But I don't know why this is in a retinotopic mapping. That's I have no clue. That comes to the more mathematical things that I can't. I think I really need to study for 1 year, just IIT, something like that, or mathematics.
And your boss supports something called neural representationalism.
Neural representationalism, yes.
Okay, and is that hugely different from IIT?
So yeah, that's there are some differences from IIT, and more in terms of neurobiological mechanism. What I agree is that so all of them active inference, neural representationalism, and IIT they somehow, I don't know, support is a good word, but support in a way that it's mostly visual cortex or posterior part of the brain are involved in consciousness theories, because some other theories say completely different things. It's posterior part is not important, but the frontal part is more important, something like this. So there are something in common, but just how consciousness is regulated is different. So both neurorepresentationalism and active inference, those are based on the predictive processing. And so you need some both, at least like in terms of neurorepresentationalism, you need both bottom-up and top-down regulation of neural communications. IIT doesn't require this. So IIT claims that consciousness can be arise only in the posterior part without any feedback from frontal cortex or some other part of the brain.
Okay.
But neurorepresentationalism is because of predictive processing. You need more higher processing. So that's some differences.
Okay.
And more like neurobiological mechanism of this is different from IIT. Yeah. And active inference, it's more or less the same thing. Yeah. Same thing, but slightly different.
Okay. Do you happen to know if these three theories, neurorepresentationalism and IIT, they arose in a similar time, or like they were, IIT was the predominant one, and then there were like newbies coming in for competitors?
Yeah.
Ah, okay.
IIT was the one that has been discussed long time, and then rest came later.
Ah, okay.
Yeah.
I see.
So that's why last two, neurorepresentationalism and active inference is not as known as popular. I'm not sure what popular is a good word, as known as IIT.
I see. You said you were you wanted to do consciousness research for a long time, or like was it a new thing that came up when you finished your PhD, or?
Oh, not particularly. Actually, when I started my PhD, I was planning to get involved in not consciousness research, but something related. So when I started my PhD, initially I was supposed to work on a project related to coma, this vegetative state, right? And it just didn't end up. So I started my PhD actually with this, but I had to change my project during my first year because of some completely other related stuff, but my PhD is still related to consciousness. It's so because my PhD is about different brain states under anesthesia.
Yeah.
So brain states is something very well connected to consciousness.
Yeah.
Of course. Yeah. Even like while you're sleeping or awake, like for example, like when you are sleeping, you're unconscious. When you're awake, you're conscious. So it's clearly transition of brain states is a transition of consciousness, right? So that it is related, but it's just a different type of experiment, I would say.
Do you remember why you wanted to do such type of topic?
So this.
No, like in consciousness in general. You said you wanted to do something related to consciousness.
Yes. So that was
high school.
No, it's quite a big deviation actually. So how I studied my science was because I would say like my interest changed a bit as I know more about neuroscience. Was it? So when very first beginning when I studied my science, that was after my high school actually. In the States, so all of my grandparents I have 4 grandparents, right? All of them have Alzheimer's disease. Developed Alzheimer's disease. So I really wanted to get involved in Alzheimer's disease, memory-related stuff. So when I studied my bachelor, I studied biology because to understand Alzheimer's, right? If you want to get involved in Alzheimer's research, you have to study biology. You have to know how body works or how biology works. So I studied my biology, and then during my bachelor, I was doing Parkinson's disease-related research in animal, but more in molecular biology. So it's like about how mitochondria but affects in the Parkinson's disease, blah blah. But this was on the microscope using like genetic studies. I didn't see any of course, this is what's contributing to Parkinson's disease, but I didn't see any connection with Parkinson's disease. The reasons are clear, right? Because you're just looking at the microscope all the time, not even human Alzheimer's, Parkinson's disease-related patients, but just looking at the mitochondria, doing genetic stuff. So I wanted to do something more, I still wanted to do memory and Alzheimer's disease research, but I wanted to do something I can see the results, as something more clearly see that, I'm doing Alzheimer's disease research. So then I did my master in memory in aging. So how memory degrades in aging. The reason is because Alzheimer. So then during my bachelor and master, right, like when I was studying Alzheimer is not the one disease. You have many different kinds of dementia. Depends on what kind of dementia you have. Yeah. Alzheimer's is just part of it, right? So that they're full of different dementias. Yeah. So you cannot really cure Alzheimer's, right? If you want to really contribute to dementia, because contribute to memory loss. So then I was like, okay, maybe not. I shouldn't study for Alzheimer's only, but I want to contribute to research something improves the memory in general, not just Alzheimer's. Yeah. So then I started my master project with memory in aging, but in healthy participants, but with a human EEG. Yeah. And then while I was doing human EEG study with a memory in aging, that was also another problem, that with the EEG, with studying memory, you don't see anything basically. So it's that's pseudoscience to me, And if you study psychology, there are so many different, even memory, right? There are so many different theories of memory, blah blah, whatever. People just claim different things without any, concrete, evidence. Yeah. And just for me, it's full of bullshit. It's like it's philosophy, or it's a discussion. It's not the science to me. And when you look at the EEG data, of course you see some, P300, P200, P2 whatever. Yeah. Yeah, of course there is change in brain, of course, right? If something happens. Yeah. But you can't see anything basically. So I thought, okay, this is just waste of time, literally. So then I wanted to do animal study. And then, but during my master, although I was doing memory in aging, of course, because it was a more study about clinical neuroscience as well. I also see a lot of different examples of different neural disorders, right? And I thought, so somehow, I don't remember how it went to, but I thought I wanted to study something more fundamental than memory only, something, more consciousness related, as memory loss is only part of brain as only few, I don't say few population people, but it's more smaller scale of people who get to develop this memory loss. Yeah. But something consciousness is not only about coma or vegetative states, but sleep disorders or really more fundamental. That's a system that all animals share, right? Like memory studies, for example, if you want to do memory studies with a fish, maybe you can do it, but it's not. You cannot compare. Like it's much more difficult, right? But this kind of consciousness is something all animals share, at least share. So that's why I wanted to do something a bit consciousness related, but more disorder related. So like a coma, vegetative state, locked-in syndrome, those kind of related stuff. So then I started my PhD in coma, but because project found that to be a bit deviation, with the deviation, I started doing slightly different things, but something similar to timeline. Okay. Yeah. And then I remember during my PhD, I listened to the talk of Masataka, and then he gave a presentation. It was about how his plan of consciousness research, how you could communicate with the machine. It's the brain-computer interface, right? With the machine and left and right hemisphere using computers, so that you can, people can also communicate. People who has even if you lose one hemisphere, you may be still able to communicate with outside world or something like that. That also made me much more interested in consciousness research, which is just very similar or same research line I'm doing now. More really consciousness related research.
Okay.
Yeah. So there are several factors that influenced, but yeah.
That was a long journey.
Yeah, it was a long, long track, but yeah. But that's how. Yeah, it was difficult to explain. So yeah.
That's pretty cool.
Yeah. But yeah, so I like to contribute to something that can apply to more number of people, not like someone specific. Like that.
Okay.
Yeah.
Pretty cool.
Yeah.
Yeah, I hope your research helps
thanks.
humanity
Yeah.
in the future.
In the future, yes. Not while I'm alive, I guess. Yeah.
Yeah, and thanks for the interview. It has been fun listening.
No problem.